Hi everybody. I think it's really great actually that we've got such a intimate setting, because that means you can interrupt us at will. I wish that we were in a room together, but with a small group it makes it closer to being, I was saying this earlier to Taryn, it's a little bit more like being in the pub. I'll let Ross introduce himself in a second. I'm Field CTO here at Kong, based in EMEA. And the reason why I'm particularly interested in this poll question that Taryn shared is I'm seeing a trend across Kong users, Kong customers, every single industry, and pretty much every organization. I've been running this same poll for many events now over the past several months. I've got a few hundred responses in, and there is a very consistent theme that 80% of people are struggling to deliver with both speed and quality. And this is a subject that both Ross and I are incredibly passionate about. We're not necessarily going to go into detail on that today, but this is a particularly interesting topic when it comes to how we're innovating in the roadmap, some of the other events that we're hosting. So this is another talk track that we are happy to pick up at a later date with you. Ross, do you want to introduce yourself before I crack on?
Sure, yeah. So it's great to see everyone. My name is Ross Mcdonald. I am a Kong solutions engineer based out of Houston, Texas. And just like Melissa mentioned, so I come from a background focused around API design and API governance, and I'll be running the demo today.
Thanks, Ross. As I said, please feel free to unmute yourselves at any point, type away in the chat. Overall, I'm just going to spend a few minutes kicking off by talking about why we're seeing connectivity become such a difficult problem across all of the users that we speak with. Then we're going to introduce you to Kong Konnect. You might be familiar with Kong Gateway. Kong Konnect is the same but different. So we're going to introduce you to what Kong Konnect is. That's really going to be all Ross, just actually giving you a tour of the real technology. And we've left time at the end for questions, but as I said, please feel free to just interrupt us. Taryn said a couple of minutes ago, don't be afraid to use the Zoom reactions. Now here, I'm going to explicitly ask you to use your Zoom reactions. If we were in person, thanks Taryn, or you can turn your videos on and give us some hands up in real life, because if we were doing this in person, I'd be asking you to put your hands up in the room. So instead, pick your favorite Zoom reaction, get ready to click it. If you have heard the term digital transformation come up at any point for you in the last month, you can see a heart from Taryn. What about cloud native? Service mesh? The well-known phrase, monolith to microservices. Yep, seeing thumbs up. Thanks, Jessica. There are so many buzzwords floating around. I, for one, am really sick of hearing these buzzwords. They've become completely meaningless. But what is interesting is they all come from the same place. We are hearing these buzzwords all the time because every single organization is under pressure to innovate somehow through technology. According to our latest digital innovation benchmark, the majority of respondents say that their organization will be out of business in under 3 years if they don't innovate fast enough. And we are seeing this very clear trend, regardless of industry, company size, level of maturity with APIs and microservices. Different organizations are at different points, buzzword time, along their journey, but the key approaches are the same. This is, on the left here, integrating into the monolithic applications that you just cannot change. I know so many organizations that are operating a mainframe still. For example, one insurer that I speak with has a system called L70. 70 because they built it in 1970. So we use connectivity, we use APIs to connect into these legacy monolithic applications that are just impossible for us to decompose or to remove at this time. We still need to work with them though. The second of the approaches that we're taking is when you can decompose that monolith and start to bit by bit refactor it into microservices. This is that monolith to microservices journey. And the third approach that we're seeing is building new capabilities from day one as cloud native applications, different mindset, different technology stacks. This is how we need to plug in new emerging technologies that add a whole load of capabilities into the business that we didn't used to have. And the more of this that organizations do, obviously, the more and more agile they become. So the more that you can innovate and spend time on the exciting parts of technology and connectivity, rather than just the boring bits of keeping the lights on and trying to mitigate risk of these systems still trying to run somehow. Now, this is all in response to the way that our landscapes are evolving. Not that long ago, the left-hand side of this graph diagram here, we all relied on the monolith, right? We had not that many apps, everything was on premise, loads of it was JVM based, there was a pretty slow pace of change. Our environments were really quite homogeneous. They were very much the same. And the majority of organizations that we work with are on this modernization of the monolith journey because moving away from this static environment is difficult because change was never really factored in as a constant back then. But I am teaching everybody to suck eggs here, I'm sure. We're no longer in that environment, right? Things are now so much more complex. We've seen cloud environments emerge, Docker, Kubernetes, automation, microservices, serverless platforms that we need to build on, new types of programming languages, new types of application development patterns. There are different teams now and team structures in organizations. Technology is something that is significantly more accessible to end users and end developers than it used to be. This means that the world that we're in is now so much more complex than it used to be. We don't just have a couple of systems anymore. We've got hundreds, we've got thousands. And therefore, connecting these systems together, there's obviously a growing number of services. But making this harder, these services aren't the same as each other. There's a growing number of different types of services, different types of protocols, different types of use cases, different technologies that they're running on as well. Everything is becoming more complex and more distributed than before. And this means that the ways that we're used to actually managing, reducing complexity just don't match anymore with this landscape. It doesn't just stop there. There are new types of connectivity that we also need to manage now that we didn't used to have to. There's connectivity within applications. This is breaking our monolith down into microservices. We have a group of microservices acting together as one applications. Those microservices need a reliable way to communicate with each other. They need a way to discover where each other is. We need load balancing between the microservices. We need security applied, particularly if we're going across network boundaries. This is where we're seeing technologies like service mesh play a key role. We've also got connectivity needed between all of the thousands of applications within a business. This is more of the kind of internal API use case. This is connecting up our monolith that we can't change to our microservices-based application, to our cloud native apps that we're building today in Kubernetes. And then we've also got connectivity needed at the edge, exposing our APIs to partners, to consumers, to the general internet. This is thinking about exposing our API or our service as a product. If we're doing it as a product, right, it's something that maybe we monetize it, maybe we don't directly monetize it, but it's a part of our business. It's part of our reputation. It's part of our product set. It needs to be reliable. It needs to be secure. How many, I'm not going to name any names. I'm sure we can all think of a couple of very recent examples of companies that have been in the press recently for data breaches or really bad malpractice because their API security has just not been good enough. So In order to do connectivity properly, follow best practice now, the requirements that we have from our behaviors, from our technology, are much more varied. We need to provide end-to-end connectivity. That's what we just looked at, the connectivity within applications, between applications, and at the edge across different network boundaries. We need to support not just an on-premise environment or a specific cloud provider. We need to support anything and everything and all of the various things that exist in the middle between that. Because innovation, right, is getting a new technology, sticking it in really quickly, playing around, developing a prototype. If you don't have or provide engineers with the freedom to do that, you're preventing innovation. Hybrid and multi-cloud, I think we are all very familiar with these terms. Obviously, it's a requirement that every single part of your stack needs to support. Things need to be Kubernetes native as well. I remember not even that many years ago talking about Kubernetes as an emerging trend. Kubernetes is just a common requirement now, right? It's not an emerging trend. It is part of every single organization's landscape. I think it was the CNCF did a survey recently, and it was in the high 70s of respondents said that Kubernetes was part of their production environment or would be within the next 12 months. Your connectivity needs to be fast, it needs to scale, it needs to be secure. If we think about what the outcome of digital transformation is meant to be, it's providing innovative digital experiences, right? It's providing personalized customer and employee journeys throughout their life cycles with you. The only way that you can do this is by making data available in the right place from all of these different systems, making it available in the right way to the right audiences. Therefore, you have to make sure that the data can travel quickly, be secured appropriately, and be presented appropriately. Innovation depends on something being extensible. Innovation is creating something new that doesn't already exist. How can you do that? If you can't build your own add-ons, if you can't get stuck into the code and extend it to cover niche use cases you might have, maybe that's like specific legacy requirements. Maybe it's like ultra cool, innovative things that are sandbox projects. And then supporting all of this, obviously, has to be a layer of automation, because there is no chance of doing this manually and being efficient. Basically, what we end up with is a whole load of pain, complexity of different systems, different teams, different platforms. Everything is different. And if we don't harness this complexity properly, it leads to pain and it leads to risk. For example, I'm sure it's the same with you, Ross. I speak with a lot of organizations that have got every possible API gateway somewhere in their infrastructure, because each one is either owned by a different team or supports a different use case. And they are telling us over and over again, because my APIs are spread over all these different places, I've got no way to promote API reuse. It's really hard to make sure that every endpoint is secured and that we are compliant. So instead, what we need is a way to plug in to every single service, every deployment environment, every topology, every protocol, and bring all of this complexity together from a management perspective, while still supporting and enabling all of these different distributed deployments, plus enabling new technology to be plugged into the landscape that might not have been factored in. And this is how we're building Kong Konnect. It supports you in building an end-to-end connectivity fabric that makes the data available anywhere it needs to be in the ecosystem. And by this, if you're familiar with in mathematics, if you're familiar with how you can think of graphs, multi-dimensional graphs with edges and nodes, or if you come from a networking background and we think about networking with lots of different nodes and edges, really what we're thinking of with a fabric is connectivity that exists in multiple dimensions, in multiple directions, with multiple protocols and use cases. And essentially this like multi-dimensional living, breathing fabric that plugs in and easily kind of rips out any services that need to get data, need to push data in, get data out, whatever it might be. So this is how we are thinking of, and this is how we are supporting users, Kong users, in building up connectivity to manage this complexity. There are three key pillars to this. I'm going to very quickly go through them and then hand over to Ross. So the first is that all of the services, the connectivity services, the APIs, the microservices, the GraphQL services, et cetera, they all need to be well designed. They all need to be secured and managed. They all need to be discoverable, right? Otherwise, they might as well not exist. So essentially, all of the ways that we support the full API lifecycle for RESTful APIs, you still need to support the relevant parts of that and apply that to all the other types of services you have. You need to be able to make sure that not just RESTful APIs, but any type of service you have can be plugged into your fabric. So this is APIs, microservices with a service mesh, and all the other protocols. The way that I like to think about this, and one of my lockdown projects was catching up on some films that I've never seen. The way that I like to think about this is it's a bit like the Avengers. Each one of our services is a bit like each one of the Avengers, right? They come from a different world. They fulfill a different use case. They've got a different superpower, but they know, S.H.I.E.L.D. knows how to contact each one of these services and say, right, this is the problem that we've got. These are the baddies that we're currently trying to fight. And you, Iron Man and Captain America, are the individuals with your superpowers that we need to gather together and achieve this outcome. So we need to be able to very quickly assemble our services together in existing ways, in new ways, to build out various different types of configurations. The second principle that we have when we're building out Kong Konnect is this needs to exist, not just in one place, but absolutely everywhere across the ecosystem. Not have one particular code base for on-premise, another code base for Azure, another code base for GCP, but exactly the same runtime and a very, very lightweight runtime so that it's very easy to deploy anywhere, scale out. The way I think about it is deploy what matters, where it matters. And this is whether or not you're running as a SaaS, which is one of the key new features in Konnect, or if you're self-hosting, or if you're doing both. The way I think about this one is this needs to exist across the entire enterprise, right? We are building this fabric that can stretch in real time in any direction. We need to support this across the entire ecosystem. And finally, like we said, this is impossible to do without automation. Managing connectivity, managing complexity in any tool and any environment has to be supported by end-to-end automation. And by this, I mean declarative configuration. The ability to say, hey, runtime, this is what you need to look like after a deployment. You take care of figuring out how that's achieved. I mean, moving on, not doing imperative anymore, although we support it, but moving on from imperative and not having to bother with writing all of these very specific scripts as to which platform APIs to call and when. It's only through this automation that we can deploy with speed, but also embed consistency into how all of these different types of APIs and services are being deployed and managed by different teams. The thing I think about here is a bit like Professor Moody, but rather than constant vigilance, what we need is constant delivery. Ross, I'm going to hand over to you. Let me stop sharing my screen. I'll also just have a quick look in at the chat. Please feel free to put any questions you've got in there, whether it's on what I've just said or throughout Ross's demo as well.
Perfect. Thank you, Melissa. Can everyone see my screen here? Right. All right, excellent. Right. Okay. And so here, this is the Connect interface. And so here it lives at connect.konghq.com. And before I go in here real quick, I did just want to highlight the architecture that we've set up here. And with the idea being, much like Melissa was just talking about, you should be consuming the connectivity within your environment, not creating it. And part of that is facilitated by the Kong hybrid mode. And what this allows you to do is separate out the control plane. So this is, what policies exist, what services exist, what routes, everything that has to do with the developer portal. Separate that out from the actual proxy data planes. And these are what is actually ferrying the data between the clients and the upstream services, with the benefit being that, Kong handles all of this portion for you. So you don't need to host a database. You get access to the user interface. You have access to the dev portal. Very easy means of interacting with the service, applying your configuration, having a single place where every member of your team can go to quickly both see what else is out there, create new runtimes, manage the dev portal. But it also allows you to very quickly and easily sprinkle these proxies throughout your environment. And one of the main benefits of Kong in this case is that we have support for pretty much every environment. So regardless of whether you're in virtual machines, dedicated instances in a colo somewhere, containers, Kubernetes, pretty much anywhere, both across multiple clouds, multiple availability zones, hybrid cloud setup, you can support, we do have those as supported configurations. And so you can see here where I have these data planes, put them anywhere. In this case, I'll be running some here locally, but I have some that are in the cloud running in a Kubernetes cluster, managed centrally, all within this single interface. And so when I first log in, the first thing I'm going to see here is Service Hub. And this is an inventory of all the services that exist within my organization. The beauty of Service Hub is that I can link these to developer portal instances. So as consumers of my APIs come in, they want to know what services exist, where they live, how to access them. I can link them here. This can also be the case for services that are not even managed by Kong. I can create service entity stubs for services that I may want to just expose as documentation, but I don't actually own or manage here directly within the Kong interface. And before I go too deeply into any of these services, I do want to highlight as well the Runtime Manager. And so getting back here to this diagram, what we're seeing here in the connect.konghq.com interface is the control plane. When we say runtime, we're really referring to these API proxy gateways. And this is the core foundational Kong gateway that everyone knows and loves, as well with the enterprise variant as well as the open source variant. And these, again, can be sprinkled in any location across anywhere and within your infrastructure, across any cloud, any Linux operating system, dedicated instances, VMs, what have you. And then again, managed here centrally. And if I look at the Runtime Manager, you can see all the different proxies that I have deployed out within my environment, their IPs, when they were last seen, also the runtime version. In this case, I'm running Kong 2.3.2 in all my environments, as well as their status. And then I can even quickly create new runtimes with a few different means. And again, we support pretty much any kind of deployment model here. We have a quick start for Docker, just because that seems to be the easiest to get started with. We also have a Helm chart for Kubernetes, and as well as an installation path for Linux, regardless whether that's Debian or CentOS, Red Hat, Amazon Linux, what have you. Again, pretty much any option here is supported. And so if I take this script here real quick, then pull up a terminal, I'll just copy this in here. All right. And so I started a new container here running locally on my laptop. I've got port 8000 exposed. And now if I hit localhost 8000, I get this no route matched, which is actually what I'm expecting. And so it's that easy as far as how I can actually sprinkle these runtimes. The beauty of Kong as well is that I can use this as part of my development process, as part of my testing process. So it's not some monolithic huge Kong runtime sitting out there that devs need to go through special permissions to get access to. They can very quickly, easily spin up instances locally on their laptop, work locally, and then use the exact same configuration when moving to pre-production acceptance and then production facing environments. And now that I have my instance set up here, you can see, so here's the new container. And so it's, I mean, frankly, just that easy as far as getting the proxy stood up. And so now I have an entry into my service ecosystem. From here, the request will be initiated from the proxy that lives on my laptop. And so I have access to all my local services running here on my laptop, anything within my environment. And so again, you can sprinkle these proxies at every edge of your environment, have them access the different services that are managed here within Service Hub. So as an example here, I'm going to click on my accounts service. And within Konnect, we've changed a little bit of the paradigm for how we think of services, where we're now focused more around the service package itself. And accounts service here is the service package. And then I have versions of this service, some dev, some tests, some production facing, that are then the actual underlying implementation. So these are the upstream URLs that the proxies are going to be relaying traffic to and from. Here you can also see high level information about this service. So the vitals data coming through. So I can see, over the past hour here, and as an example, the service makeup of the requests going through the gateways. And this is in aggregate, so not just an individual gateway. I can see, of course, v08.2, which is my latest version, being the most popular, which is probably a good thing. I can even export this data. I can see its status within the dev portal. In this case, this service is available in the dev portal. So as I add new versions to this service, they will automatically be exposed. I can also link what we refer to as a service document, which will be used for the developer portal piece, and which I'll get to in here in just a second. But it really, provides more context, more documentation. The service document is more free-form documentation. So, a markdown file that I can sprinkle that put into the dev portal that will allow consumers to see high-level information about how they can use it. It can include how to connect, how to authenticate, tutorials, guides, what have you. It will all be surfaced along with the service definition itself. So if I click into a service package here, or sorry, a service version, my v08.2 version, for example, I get a little bit more detailed traffic stats coming from that vitals data. This data is being pushed from the gateways to the config plane here, the control plane here that lives within the SaaS environment. So no matter where these are, I'm getting the data pulled back from them. I can link an open API specification. And this is really what's going to be powering that dev portal documentation. So, as I'm developing this new service, I can use tools like Insomnia and other design tools for creating the specification, generating the documentation for it, have this live right alongside my code base, right next to the implementation, and then updated automatically as new versions of this service become available, become online, and then I'll have that flow into the dev portal so that as consumers are coming into our ecosystem, whether those are internal folks or external folks, partners, consumers, customers, developers, what have you, they have up-to-date documentation, and as well just an overview of what services are out there. And then within the service version, so when we actually get to the little more nitty-gritty details here, this is more the bread and butter of what Kong as a gateway does. So I've got the routes for this service. So this is how to map incoming requests going to the gateway to the upstream service. For example, I can send a request to the /accounts path. So let me jump over very quickly to Insomnia and send a request here. I believe this is the right instance. Yeah, so I can say /accounts as an example. And I'm going to get a 401 because I don't have, I haven't specified an API key in this case, but this shows that at least I'm actually hitting the correct service, but I'm reaching some of the policies that we have applied here. In this case, key authentication being applied on this service that prevents me from connecting without an API key. But it's here I can manage exactly how those incoming requests that hit the gateway get mapped to the backend services. I can create and modify the implementation itself. In this case, this is actually going to a local Kubernetes service that lives within the cluster. But it basically allows me to map this incoming traffic to a backend service and have all of that taken care of for me. And then, of course, have this flow into the dev portal, I can modify the routes as I need to if I want to relay more traffic into the service or redirect that traffic somewhere else. And then by applying the policies here, I can manipulate and control the traffic that gets proxied to the service. And so things like, the key authentication, like I just mentioned, as well as rate limiting, ORs, bot detection, exposing metrics through Prometheus that I can then aggregate and, alert on, have this feed into kind of a larger alerting picture that I have for any operators within my infrastructure, so they can know, what services are being used, what the status codes that are being emitted from that service, and just more on the operational front as far as kind of maintaining services over time. And so as an example here, I can see all the different plugins that I have available. By putting this here at the gateway, I also free the backend teams from having to worry about this kind of functionality. So things like caching, rate limiting, authentication, even, as well as more of these kind of more pieces of functionality that are more suited for a gateway as opposed to actually being built into every single service. And especially as the number of services in your environment grows, the more opportunity there is for different implementations of different pieces of policy here to slip in. Some that may not have been updated in quite a while, some using different languages, different frameworks, different versions of the same framework. And so by centralizing all this policy here at the gateway, I can ensure that caching, for example, is done within a consistent way across all the services in my environment. And then I have high level view and access to understanding what services are implementing these policies, how it's being implemented, and I can configure it here directly through the Connect UI. I mentioned this before, so the account service here is published to the portal already. Otherwise, I can unpublish it, but this would normally say publish if it wasn't already there. And from here, I can jump to the dev portal piece. To credentials here. And this is what the consumers or developers integrating against or building upon my services will see. And just like we saw within the Service Hub view here, we have all the different services that are available. It's not a requirement that they get published to the dev portal. So it's not always the case that I may want to have services that are not present in the dev portal. But this is an easy way to just surface both the discoverability for these services so that devs know what services are out there, what endpoints are out there, everything like that, as well as to control both, they can self-service their access to the dev portal itself, as well as their own credentials. And so if you have a lot of external developers that are building upon your services, you may find that it's cumbersome to have to send API keys or manually provision users within a given environment every time that they need access to a given API or API version. In this case, it's all self-service here, managed in a self-service manner so that developers can access it themselves. They can self-service their own credentials, see utilization, what credentials they have out there, as well as consume the documentation, both free-form as well more structured, that's linked to those service definitions here in Service Hub. So as an example, I can go into the accounts service here, where I see the service document. I'll go to my 08.2 service, where I have the auto-generated documentation coming from that open API specification. So again, consumers can see the request response structures. They can send requests directly here through the UI as they're building out their integrations. If I look here within the UI for my account here, I have my apps. And in this case, I can create let's use one of the ones that I already have, where I can create an application that defines, this is the application that I'm building upon that will be integrating with the services that are available that are exposed through Service Hub. And then from here, I can manage my credentials. And so in the case of the Octo Team app application, it has access to the accounts service. I can quickly generate a new credential, go to my instance here, specify my API key and the request. And now I can have access to the service. In this case, it's just an echo service, so it's not going to return with anything very, very useful in this case. But just to demonstrate how all this works from the consumer's perspective. If I look, I can, in the headers, I can see both this is coming from Kong, but as well, I can see this is also being rate limited. And so, again, kind of the more bread and butter type of functionality that we typically see in kind of gateway use cases, things like rate limiting, caching, authentication, can all be handled here. The backend service has no understanding of what is going on in front of it. It doesn't need to. And so the backend teams are freed from this technical debt that they eventually have to repay over time. And they can focus on building their service and integrating with the other pieces and again, consuming that connectivity, whether that's north-south and the kind of the gateway use case coming from outside the environment into the environment, or more east-west traffic, going more of a service mesh communication. Within the dev portal settings here, I can also customize the appearance of the developer portal. So I can very quickly change how it looks, brand it a little bit. If I refresh here, you'll notice that the changes are immediate. And so again, providing a self-service avenue for developers and consumers of my API to come in and see what documentation is out there, manage their credentials, and just overall manage their access. The other piece I just want to quickly mention here is it comes around managing the developers and the applications. In this case, I can see the developers that have requested access. So I can also lock access to given both services as well as access to the developer portal in general. And so as people come in, it's not typically that they can come in and just automatically self-service themselves, that they do need to request access. And so all this does feed back into the UI here, again, where I can, from the interface, manage these requests, approve, deny, manage the dev portal, manage the services, manage the runtimes, and all this with role-based access controls as well. So you can see other members of the organization and their given privileges within the org. So I can control and scope access to given services, or depending on their role within the team. And that is it. I'm happy to answer any questions here, or if there's anything that I can drill into a little bit more, happy to do that.
Feel free to enter any of your questions in the chat, or you can speak up. If you can't unmute yourself, just raise your hand and I can assist. All right, well, I have a question, if I could ask, which may be more for Melissa, or either of you actually. How does service mesh fit into all of this?
Great question. I'll comment and then I'm sure that Ross will have some more to say on it as well. Excuse my notification. I've got this problem recently. So my laptop's on Do Not Disturb, but Google Chrome is still sounding all the notifications, and I haven't, to be honest, I haven't looked up how to stop it yet, but any tips would be appreciated. So service mesh is typically used as a slightly overlapping technology, but that solves a different problem from API Gateway. API Gateway acts at layer 7 in the OSI model, if that's something that people are aware of. It basically means that this is the presentation layer of our data. This tends to be more human discovery of an endpoint in a portal to then get some kind of access key and build an application against to consume it. Maybe that's a different type of service, maybe that's a mobile app or a website. This is API Gateway, and it manages like traffic control, governance and security, observability, insert your favorite relevant API Gateway buzzword. So it gives us all of that control over all these services sitting at that top layer. Now, going back to the journey of the monolith to microservices, or building cloud native applications and microservices in general, the communication between them is slightly different. A microservice based application tends to have a whole group of services that act together as one unit. That unit is exposed through an API and therefore has an API gateway to manage the connectivity into that unit. But within that unit, all these different services need to communicate with each other that communication needs to be secured. It needs to be made reliable. There needs to be traffic routing. But because a microservice is different from an API, because it can be built in different languages, it fulfills different use cases, it might travel over different network boundaries, because there's load balancing is absolutely critical across multiple microservices. If you have one microservice is running slowly, as soon as you make a call to that overall application, that one microservice is going to slow everything down. And we're talking about things operating on a smaller, tinier little scale in the individual services themselves, but a greater number of services. So there needs to be things like automatic discovery of services. There need to be instant traffic routing to ensure that the network itself is still reliable and can still handle all of the traffic that the microservices are going to be constantly sending back and forth. So if we take a step back and think about the overall fabric that we're building to support connectivity across an ecosystem, it has to support not just API gateway, but service mesh as well. And this is how it goes from being a one-dimensional thing to a multi-dimensional thing. So you can step back, have that complete bird's eye view and say, I need to make a call to this API. I'm going to go through the gateway. You get into that gateway, that's that north-south traffic boundary. And then, hey, actually what we're doing, this API response is going to be fulfilled by calling these 10 microservices. So then as your request, you get kind of routed between all of these services. That's the service mesh coming into play. The response is assembled, and then the API gateway handles sending that back to the end client. So the way that we are building this into Konnect, there's obviously Kuma, the open source service mesh that we've built and donated to the CNCF. There is Kong Mesh, which is the supported enterprise version on top with some extra cool features like OPA. We are building support for Kong Mesh into the Konnect control plane, which Ross showed us. So as well as being able to see all of the APIs in the Service Hub, all of the gateway instances in Runtime Manager, all of the analytics for API gateway traffic, we're going to start to get more of that applied to your service mesh data plane proxies or applied to your Kong Mesh instances, and start to understand a little bit more. This is the bit that's most interesting to me. When we're thinking about how many points of connectivity there are in fulfilling one kind of overall response, you don't want to lose the context. If you're kind of starting off, making a call to an API, going back in and doing all these things with the microservices, you want to keep that context and understand how is that one request being routed across all of these different services that are actually playing a role. So bringing Kong Mesh into Konnect is one of the top level items in our roadmap. Ross, is there anything that you want to add on to there?
No, I think that was great. No, the idea is that just like we manage the gateway, those gateway runtimes within the Konnect interface, it'd be almost identical in the sense that you'll be managing those mesh data planes. We call them data planes, but it's kind of the same naming here. And then you have a single interface where you can manage those. And so as you're managing those services from that north-south traffic, so on the outside the environment, coming into the environment, you can do the same for that east-west traffic. So that inter-service or inter-service communication, and applying same policies, have a single pane of glass to see both the north-south as well as that east-west, and a nice interface to apply that policy regardless of where it's originating. So yeah, and this is going to be probably where we're headed from a roadmap perspective, and managing this all from a single place and kind of consolidating the gateway and the mesh concerns there.
Awesome, thank you. And we have just a couple more minutes if we have any other questions or any points that you have thought of, Ross or Melissa, that weren't brought up in the presentation. Going once. Going twice.
Yeah.
All right. Well, thank you all so much for joining our meetup today. We hope to see you at future meetups, and thank you very much to Melissa and Ross for a fantastic presentation. I will be posting the recording and sending it on to you so you can share with all of your friends and coworkers. So everyone, I hope you have a great day. Thank you, Randy. And we will see you next time at our Kong meetups. Have a good day, everyone.
Thanks all.
Thank you, everyone.
Thank you.
Bye.